recording on here. Whew, so how was last week? Without any e-session, did you make it through okay? All right, now I'm just going to review a little bit about it. First semester, everything revolved around taking a derivative and finding the slope at any given point, and then writing the equation of tangent lines. Second semester deals with taking an antiderivative, which is an integral, which gives you the area underneath the curve. And we're going to be finding volumes and areas and stuff like that. But for example, in this example here, it says that this is the graph of the velocity of a train, or the speed of a train. You know, the train picks up speed, then it goes 40 miles an hour for some time, and then comes to a stop. Well, if you find the area underneath this curve, it gives you total distance traveled, which is kind of an interesting concept. And it works. It doesn't have to be a straight, I mean, it could be a function that looks like this, which gives us a lot of possibilities. I mean, when we start doing problems, finding the area, like if you had a concert and you found the number of people, how fast they were going into the thing, into a auditorium, you could come up with a function, you find the area underneath that function, it gives you the total number of people in attendance. There's so many different uses of this that it's unbelievable. So that is our whole focus for the second semester, is finding area underneath curves. Now, you should have been able to do it with last week with left rectangle sums, right rectangle sums, midpoint, and trapezoid. So there were 4 different ways that you could find the area underneath a curve. So in this problem, it says estimate the area from 0 to 4 under the graph of 16 minus x squared using 4 approximating rectangles and right endpoints. Okay, so if I was going to do this problem, I always draw the thing out. Okay, so, oops, my marker took up my area here. Okay, so it was 16 minus x squared. So way up here at 16, and then x squared, so it's gonna, that was negative x squared minus x squared, so it's gonna come down something like this. And it asked me to find using 4 approximate rectangles and right endpoints from 0 to 4. So I'm gonna go from here to here, and I'm gonna use 4 equal intervals here. So 1, 2, 3, 4. And this time it asked me to use right rectangles. If it asked me to use left rectangles, I'd start from this side. This side here would be left rectangles. This side would be right rectangles. So my first point, and I usually come up with the points right away. So I come up with these points here. So if I plug it in, it was y is equal to 16 minus x squared. So if I plug 1 in there, 16 minus 1 squared, which would be 15. So this would be 15 here. If I put 2 in here, that's going to end up being 12 here. If I put 3 in here, it's going to end up being 7. If I put 4 in here, it's going to end up being 0. So my first rectangle is just going to be 0. And then my second rectangle, because it's a right rectangle, so I'm going from the right-hand side. So my second rectangle is 7. Then my next rectangle is going to be 12. And my last rectangle is going to be 15. So if I add all these up, 15 plus 12 plus 7 plus 0, that should give me the approximate area underneath this curve using right rectangles. So what is that, 1434? Should be my answer. Now, sometimes they'll ask you, is this an overestimate or an underestimate of the actual area underneath the curve? What would you say to that question? Is this an overestimate or underestimate of this curve? Under, right, because I can see, just by looking at this graph, I can see that there's area that I didn't even add up. There's a bunch of it right here. So this is, now, if I would say, okay, I want you to use 16 intervals, then, you know, you'd have all these different intervals. Your area would be so close to the exact area underneath that curve, but it would take quite a long time. Now, when we get into finding integrals, you're going to be taking this problem and you'll be doing the integral from 0 to 4 of 16 minus x squared. Now, this is what our whole focus is going to be on the second semester. But right now, we're not going to be able, we don't know how to do this, but this is what we're going to do. And we're going to find an integral of this. But right now, we only know how to use left-hand endpoint or rectangles, left-hand rectangle, right-hand rectangle, midpoint rectangle, and trapezoid. All right, so that was last week. Here is another example. Now, this is a type of problem that you would get on an AP exam. It says a table of values for a continuous function f is shown above. If 4 equal subintervals between 0 and 2 are used, which of the following is the trapezoid approximation of the integral from 0 to 2? So if I was going to do this problem, again, I'm a very visual person, so I would do this problem. So this is 0, 3. So this point's at 3, and then I have 1/2, and that's at 3 also. Then at 1, it's at 5. At 1.5, or I'm going to just go 3/2, it's at 8. And at 2, it's at 13. Okay, so now if I want to use a trapezoid, trying to use trapezoids to find the area, all I'm going to do, now obviously this would not be a trapezoid here because same distance, so this is 3 times 1/2, so this would be 3/2 inside here. But then if I use a trapezoid here, this would, and trapezoid formula is base 1 plus base 2 times height divided by 2. Now, it's kind of weird. The height is 1/2, right? Because the bases are the parallel sides. So in this problem, it would be 1/2, and then base 1, which would be 3 plus 5 divided by 2. Or I could just put this all over 4, couldn't I? 1/2 and the 2. So this would be 8 over 4 or 2. And then I would find this trapezoid, again, height, and then base 1 plus base 2. So that's 5 plus 8 over 2. So that would really be a 4 again on the bottom. And that would give me 13 over 2. And then I could do it again using this one. So that would be a trapezoid approximation. We would find the area underneath trapezoids. Okay, so that was last week. Left-hand Riemann sums, right-hand Riemann sums, and trapezoid Riemann sums. This week, we're going to be finding area underneath curves using geometry, and we're going to have some basic integral rules. Now, these integral rules, they won't seem very interesting today, but whew, they do come in handy in the upcoming weeks. Another way of finding areas underneath curves is to use geometry and the formulas for area. Area of rectangle, base times height. Triangle, base times height divided by 2. Circle, pi times radius squared. I could throw trapezoid in there, height times base 1 plus base 2 divided by 2. Any type of formula from geometry you can use this week. So in this problem, it says evaluate the integral, and this is your starting point. So this is where we start. This is where we stop. Do you know where this integral sign comes from? And I don't know how much math you've had before, and I'm not sure if you've ever seen this symbol. Have you ever seen this symbol? this symbol right here. And that yes, it's the sum. This is the sum. This is the sum formula. So if I said n equals 1 to 4, can't see that 4, of n plus 2. You would plug 1 in here, you get 3 plus, and then you'd put 2 in here and you get 4, and then you'd put 3 in here and you get 5, and then you'd put 4 in here and you'd get 6, and then you'd stop because you started with 1, you plugged all the numbers in until you got 4, and then you added this together. It's exactly where they came up with this integral symbol. It means the sum of the area underneath the curve. That's what it means, from 2 to 5. Okay, so in this problem, if I was going to solve this problem, first thing I do is I just graph it out. 2x plus 4, so that's 1, 2, 3, 4, 2x. So it's going to look something like this. That's what my function looks like. Now it wants me to find the area underneath the curve from 2 to 5. So let's say 5 is right here. So I'm going to find the area underneath this curve between 2 and 5. Well, for me, this thing looks like a trapezoid. So I can find the exact area underneath this curve. I need to know what this point is. I need to know what this point is. Well, it's pretty easy. Just plug it in here. 2 times 2 is 4 plus 4. So this is 8 here. If I put 5 in here, 2 times 5 is 10 plus 4 is 14. Okay, so now I've got my trapezoid. I have my bases. My first base is 8. My other base is 14. The height is 3. So this is going to be 3. And then 8 plus 14 divided by 2. 8 plus 14 is 22. 22 divided by 2 is 11. 3 times 11 is 33. So the area underneath this curve between 2 and 4 is 33. So we're going to just be using geometry formulas tonight, and we're going to be finding the exact area underneath that curve. The area underneath that curve is exactly 33. Okay, and I could use calculus to prove it, but there really isn't much to prove because we know geometry, and that's pretty easy to find. All right, let's try another one. Evaluate the integral. Okay, so what is the graph of this? Do you know? What is the graph of this? Hard to explain? Semicircle. That's all it is. Here is a formula for a circle. X squared plus y squared is equal to 16. That is a circle with center at 0, 0, and a radius of 16. Now, if I solved for y, I would subtract x squared off. So I'd end up with y is equal to 16 minus x squared, y squared. And then I would take the square root of both sides. And I'd end up with this. So I'd end up with y is equal to plus or minus the square root of 16 minus x squared. Now, this does not have plus or minus. So this is just the top half of the circle. So if I was going to graph this out, what is my radius on this circle? Do you know? 4. That's exactly right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And you don't have to draw these out if you don't want to. I mean, it's up to you. I usually do it just so I can see what's happening here. But it's only the top half of the circle, and it only wants me to find it between 0 and 4. So really, what I'm looking for is this area right here. That's what the whole question is asking me to do. It's asking me to find the area above the x-axis between 0 and 4. Now, that's pretty easy because I know what this the area of a circle is. Area of a circle is pi r squared, isn't it? Well, this is only a fourth of a circle, so obviously my answer is going to be pi r squared over 4. So if I put the radius in there, that's going to be 16. So the area for this piece of the circle should be 4 pi. That should be the area of that. So we can find the area underneath curves. We can find integrals without having to know the calculus yet. As long as we can graph it out, we should be able to find the area underneath the curve. All right, I'm going to let you try this one. It says evaluate the integral. The integral from -3 to 5 of x squared minus 1 over x plus 1. So what I want you to do is I want you to graph it out. I want you to find the area underneath that curve between -3 and 5. And if you look at it and say, well, I can't really do this one, that's fine. You say that and I'll work you through it. Okay. How far did you get? Were you able to graph it out? Ah, all right. So it looks like it's going to be a tough graph, right? It's a line. It is a line. Why is it a line? Well, because the first thing I do when I get a function like this is I factor it. X squared minus 1 factors down to x minus 1, x plus 1. On the bottom, I have x plus 1. Lo and behold, these two cross out. What happens when you factor something and it crosses off on top and bottom? Well, that means there's a hole in the graph. So there is a hole in the graph at x equals -1. Why do I know that? Because it crossed off on top and bottom. Whatever makes this equal to 0, there's a hole there. So what does this graph look like? It looks like this. It looks like x minus 1. This function here is the exact same thing as if I asked you to do this problem. So if I graph this out, x minus 1 down here, well, at -1, I know there's going to be a hole in that graph. So that hole is at -2. So there's a hole right here. Well, my graph is going to look like this. There's a hole there, which is no big deal. I mean, just because there's a hole doesn't mean I can't find the area underneath that curve. So I'm going to find the area underneath this curve from -3 to 5. Okay, now here is a very, very important piece of information. Area underneath the curve is negative. I'm sorry, area underneath the x-axis is negative. Area above the x-axis is positive. So now if I'm going to solve, if I'm going to find the area, this is at +1, isn't it? So below the x-axis, I go from -3 to +1. What is this point here? Because this is really a triangle, right? So my base is 4, because I go from -3 to +1, so that's 4. -3, so if I put -3 in here, this is -4 here, isn't it? So this is going to be 4. So the area of a triangle is just base times height divided by 2, so this is 8. But it's going to be -8 because it's below the x-axis. So now I have to find the area above the x-axis. Well, that goes from 1 to 5. Well, that's 4 here. And then if I put 5 in here, oh my goodness, this is 4. This has an area of +8. So the integral from -3 to 5 of x minus 1, or this whole function here, is equal to 0. Because the area above the x-axis and the area below the x-axis are exactly the same. They cross themselves off, and you end up with an integral equaling 0. Pretty awesome. Now, if you can't graph that function, it makes it a whole lot harder, doesn't it? But anytime you have a function that can factor, make sure you factor it out. It is going to help. Does that make sense? All right. Now we're going to talk about some rules. If f is defined at x equals a, then the integral from a to a of f of x d of x is equal to 0. This one is the most obvious one in the world, I think, because if I gave you the integral from 2 to 2 of 5x plus 4, well, if I graph it out, it's going to look something like this, right? But if I'm going from 2 to 2, area here. So anytime you have an integral that goes from the same number to the same number, it's 0. The area under, you can't find area if there's no width to the problem. Okay, so that's one integral. Now, when you have, and this comes into play a lot, if you have a problem like this and you have 4 to 2, integral of 2x, let's say, plus 5. This is an incorrect integral. Why is it incorrect? Because you can't go backwards on an integral. You can't have a larger number on the bottom and a smaller number on top. Well, how do we take care of that? Well, we can rewrite it with a negative in front and then flip the numbers. So the integral from the negative integral from 2 to 4 of 2x plus 5 is exactly the same thing as this. So if you ever have a number on the bottom that is larger than the number on top, you have to flip it. And the only way you can flip it is by putting a negative out in front. So these are two special definite integral rules that you have to know. Okay, so here's a couple examples. Okay, so problem or letter A, what would your answer be there? 0. That is correct. Now, obviously B is a little bit tougher, so I'm going to give you a couple minutes to work on that. But what would your answer be for letter B? Okay, I'm going to let you work on it, see what you get. No answer yet for part B? Stuck. Okay, the first thing I'm going to do in this problem is I'm just going to rewrite this as the integral from 0 to 3 of x plus 2. Now I'm trying to find the area underneath this. Okay, so positive 2 going up like this. I'm going from 0 to 3. So this is 0. This is 3. Looks like a trapezoid. So at 0, I'm up at 2. If I put 3 in here, it looks like it's 9. Oh, no, I'm sorry. That's 3 plus 2. That's 5. All right. So my trapezoid My bases are 2 and 5, and my height is 3. So I'm going to go 3, 2 plus 5, divided by 2. So 2 plus 5 is 7. 7 times 3 is 21. 21 divided by 2 is 10.5. So my answer is just going to be negative 10.5, because that negative sign in front is just going to make it negative. Okay, now, questions. Where did you get stuck? Okay, and you always have to remember, whenever you see an integral, the first thing that should be going through your head should be, oh, I'm trying to find the area underneath this curve. Okay, now tonight, all of them will be able to be solved by, using geometry. That's it. Now, when we get farther along, you're going to be given integrals like this: the integral of x squared plus 4x plus 5. There's no way you can find the integral or the area underneath this curve without using calculus. But tonight, all of them, you'll be able to use just geometry to figure it out. Okay, so here are some more properties of definite integrals. First property, it says, basically what it's saying is, if you're given a function, like if you were given the integral from 4 to 10 of 3x, anytime you have a constant in front of a function, you can rewrite that as 3 integral 4 to 10 of x. That constant can be brought out to the front. Makes no difference. You can do it that way. Most of the times we don't. We just leave it in there. But sometimes it's worth pulling it out. Okay, so that's basically what this first one says. Second one, it says that if you're given an integral from, let's say, 2 to 7 of 3x squared plus 4x plus 5. What this one is saying is you can break this up. You can break them, if there's a plus or a minus sign in between there, you can break it up into separate integrals. You could rewrite this as the integral from 2 to 7 of 3x squared plus the integral from 2 to 7 of 4x plus the integral from 2 to 7 of 5. Boom, done. That is what that integral or those properties are telling us. Okay, and these properties are going to be very, very important in the near future. Okay, so what I'd like you to do is I'd like you to try to solve this problem. It says the integral from 1 to 3 of x squared dx is 26 over 3. The integral from 1 to 3 of x dx is equal to 4. And the integral from 1 to 3 of dx equals 2. Okay, so give it a shot. See if you can figure out what the answer would be there. And I have I'm not sure if you can hear me or not. Can you still hear me? Okay, I had that spinning wheel And I didn't know if you could hear me or not. Okay, so you ended up with negative 6 2/3. All right, let's take a look here. If I was going to do this problem, now I'm going to tell you you're not going to do this when we start finding integrals. You're just going to take the integral of the whole thing. But I can rewrite this as the integral from 1 to 3, and then I can put -1 out in front, x squared, plus, and then I'm going to pull the 4 out in front and say that this is 4 times the integral from 1 to 3 of x minus the integral from 1 to 3 of 3. Okay, so here's my problem. I know what x squared is. It's going to be 26 over 3. I have a minus in front of there. So this is going to be negative 26 over 3. Plus, I know what the integral from 1 to 3 of x is. It's 4. And I have a 4 out in front. So that's going to be 16. Minus. Now, this one has no bearings on the whole problem. Okay. Integral from 1 to 3 of 3. I have to figure that one out. Well, what is 3? Isn't 3 just a horizontal line? So this is 3. I want to find the area underneath it from 1 to 3. So isn't that 6? So the answer here is 6. Yeah, they put that in there to trick you. So the answer there is just 6. So now I can put this together. So 16 minus 6, so that's going to be 10. So now I have negative 26 over 3 plus 10. I suppose I would make this 30 over 3. So my answer would be 4/3. For an answer? Okay. So I'm sure, did you get the first two parts right? The negative 26 over 3 plus the 16? Okay. And that last part, and that's, I think that's one of the rules that is coming up next, is that when you have a constant, you know, if I gave you the integral from 5 to 10 of 7, well, 7 is a constant. It would be just a horizontal line at 7. If I wanted to find between 5 and 10, now I'm just finding the area underneath the curve. So that would give me 5 times 7, which is 35. So anytime you have a constant, it's pretty easy to find the area underneath the curve there, because it's just a horizontal line. All right, so here's a multiple choice problem off a previous AP test. It says the regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. If the area of each region is 2, what is the value of the integral from -3 to 3 of f of x plus 1? I'm going to let you work on it. I know you're going to get it wrong. Why do I know that? I've been doing this for a long time. Give it a shot, see what you get, and then I'll go through how I would work that problem out. Stuck. Okay, so they tell us that all of the areas are going to be 2, right? So they're trying to trick you in the first place, because you got to know that this would be a -2. It's +2, -2. So now I'm going to rewrite this integral. Integral from -3 to 3 of f of x. Well, that one you should be able to look at and tell me what the answer is. -2 plus 2 plus -2, that's just -2. plus the integral from -3 to 3 of 1. So what's this answer? What is the area underneath 1 from -3 to 3? And remember, if it's a constant, just a straight line across. So what would the area be underneath that between -3 and 3? 6. That's exactly right. So now I know what this is because I had to use the graph, and I know that underneath the x-axis is negative, above is positive, so -2 plus 2 plus -2 is -2 plus 6. My answer is 4. Done. Pretty awesome problem. Really gets a lot of things across in that problem. Knowing that area underneath the curve would be negative, area above the x-axis is positive, the area of a constant is just going to be 6 on this one. It's a good problem. All right. Okay. This one takes that concept to the next level. When I first started doing this, when I first started doing calculus and I saw this problem, I'm like, oh my God, I don't have a clue what to do here. So first thing I did is I looked at this and it said, if the integral from a to b of f of x dx equals a plus 2b, then what is this answer? What is the integral from a to b of f of x plus 5? Well, the more I think about it, it's like, oh, they're really seeing if I understand this concept right here. Because I already know what this is. I know what the integral of f of x is. It's a plus 2b, isn't it? So the only thing I need to do is I need to be able to figure out what the integral from a to b of 5 is. Well, again, 5 is a constant. If this is a here, and this is b here, and I don't know what a and b are, what is the area of this thing? Well, I always look at it like this. It's like, okay, if this was 2 and this was 5, what would this distance be? It would be 3, wouldn't it? And how did I get that? Well, I subtracted this number, or I took this number and subtracted this number. So the distance here is b minus a. The height is 5. So the area of this thing is really 5 times b minus a. That's what the area of this thing is. So that's what I did here. And then I just did plus 5b minus a and multiplied through by 5. So that gives me 5b minus 5a. I have a plus 2b over here. So my answer would be what? Negative 4a plus 7b. Pretty amazing problem. Do you think you would have gotten that one? I mean, it really isn't that hard, but man, when you first look at it, it's like, whoa, what am I supposed to do in this problem? And it's like, okay, I got to take this step by step. But I think it's a really good problem. Really like that one. All right. This one, I'm going to let you do. We've done enough of these. Okay, so this one you should get. Keep my fingers crossed. All right. So why don't you work on that and see what you get for an answer. It's absolutely correct. 12 is right. Because in this one, yeah, and sometimes you don't even have to do a whole lot of work in these things. I mean, you're looking at this and it's like, okay, so I've got 2 to 4 of f of x. Well, they already told me what that was. They told me it was 6. Plus, well, the integral from 2 to 4 of 3, well, right away I know that's 3 high. So that's my height. And then 2 to 4 is just 2. Well, that's just 6. 6 plus 6 is 12. Very good. All right. Last problem for today. I think this is part of the assessment for this week. Gives you a function, okay? And it asks you, what is the integral from 0 to 2 of f of x d of x? And the d of x just means that that's a derivative there, so don't have to worry about that. And what's the integral from 2 to 6 of f of x d of x? Okay, and then I'm going to add one more to this problem, okay? I'm going to add c. I'm going to let you work on it for a little bit. So I want to know what the integral from 6 to 2 of f of x is. Okay, so I want you to try to solve A, B, and C. See what you get for answers there. And then you are done for the week. Well, you're not done because you still have assessments, but negative 2 pi, 8, and negative 8. Oh, man, that was pretty quick. You really caught on to this stuff. Okay, now I don't know if that's right or not, but so 0 to 2, it's below the x-axis. The radius is 2, so that's pi r squared. I'm going to divide that by 4 because it's a semicircle. And so that's 2, so that's 4, so that's pi. And it's negative. Oh, I got negative pi. Okay, because this pi r squared is a full circle, right? So if I only want a fourth of it, I'm going to divide by 4. So I'm going to go with negative pi instead of 2 pi, okay? Is that all right? So I'm going to go with negative pi here. Okay. Part B, I'm going from 2 to 6. Okay, so that gives me 1, 2, 3, 4. So my base is 4. Height is 2. Oh, you don't know how to find the area of a triangle, do you? Base times height divided by 2. I'm going to go with 4 here. unless I did something wrong there. 1, 2, 3, 4. So the base is 4. The height is 2. Okay, so I'm going to go with 4 because a triangle is base times height divided by 2. and then this one would be just the opposite of it, so that would be negative 4, right? So all right, so geometry must not have been good to you, right? So you just be careful. I mean, and this type of problem is on the assessment tonight. I think the same graph is on there, and I think it probably asks like 6 different questions using the same thing. Just have to be careful on, how, finding the area under each one of those geometric figures. I know we've had quite a bit of time off. Hard to get back in the groove. All right, that is it for today. I'm going to go and open up your lessons because I know you understand the material. You don't have to do any other work there. So I will have those open up so you will be ready to go. You have a good week, okay? Bye.